Okay, let's unpack this. You know that feeling? Like when something fuzzy just snaps into focus?
Oh yeah, like put it on glasses for the first time.
Exactly. And you suddenly see like leaves on trees. That's kind of the feeling we're talking about today.
Mm-hmm.
We're looking at how you take lower res images, maybe video, and make them look, well, stunning on these super sharp high res screens you probably have now.
Yeah, it's a common problem, isn't it?
Totally. You've got this amazing 4K TV, maybe even 8K, right? Millions of pixels just waiting.
Ready for all that detail.
But then you watch an old movie, or maybe even something streamed in 1080p, which is still good, but...
But it's not 4K. Not even close, pixel-wise.
Right. And when you stretch that smaller picture onto the big screen, just looks kind of fuzzy, muted.
Yeah, it definitely doesn't take full advantage of the display. And that mismatch is really where this whole idea of upscaling comes in. But not just basic stretching. We're talking about AI upscaling. It's a much more, let's say, sophisticated solution.
More than just making it bigger then.
Exactly. It tries to make better. So in this deep dive, we're looking at some great info, drawing from places like NVIDIA, BorisFX, TechRadar.
Sources.
Yeah, really solid stuff. And we're going to figure out, what AI upscaling is, how it's different from the older ways, and crucially, where you're probably already using it.
Maybe without even realizing it.
Quite possibly. On your TV, maybe a streaming gadget, your computer, gaming even.
Okay, so the mission here is to kind of demystify this tech. Make sense of how it takes old pixels and gives them new life.
That's the plan.
So let's start with that basic problem again. You've got the 4K TV, maybe 8K. How big is the difference when the source is, say, 1080p? Or even older, like 480p standard def?
Oh, it's a huge gap.
Yeah.
Huge. Think about it. 1080p, that's full HD, right? It's about 2 million pixels.
Okay.
A 4K screen has over 8 million. So your TV needs to invent like 6 million pixels just to fill the screen from a 1080p source.
Wow, okay. 4 times the pixels.
4 times, yeah. And 480p, standard definition, that's maybe 300,000 pixels.
Tiny compared to 4K or 8K.
Tiny. Trying to make that fit an 8K screen, which has like 33 million pixels, you can see why just stretching it doesn't work well.
Right, so the TV has to fill in all those missing spots somehow. What was the old way before AI got involved?
Well, the simplest method, basic upscaling, was pretty crude, actually. It just copied the pixels it did have and repeated them.
Like a copy-paste job?
Kinda, yeah. Imagine taking one pixel and making it into a block of 4 or 16 or whatever was needed to fill the space.
That sounds like it would look really blocky, jagged edges.
Exactly. Really harsh. So they added filtering, basically blurring those sharp, blocky edges to smooth them out.
Ah, okay, so it fits the screen, but...
But it doesn't add any real detail. It just makes the lack of detail less jarring, I guess. The image often looks soft, maybe a bit smeary or muted.
Because you're just stretching the information you already had, thinner and thinner.
Precisely. And that's the limitation. That's what AI upscaling is designed to overcome.
Okay, so this is where it gets really interesting. If the old way is just stretching and blurring, how does the AI approach work? You said it. Predicts. It creates stuff.
Yeah, it's a completely different mindset. It's not just making the existing pixels bigger. It's trying to figure out what the high-resolution image should have looked like in the first place.
How does it do that?
Think of it like, okay, imagine you give a blurry photo to a really skilled artist.
Okay.
But this artist has studied millions, literally millions, of sharp, high-detail photos.
Yeah.
They know what sharp edges look like, what textures like wood or hair look like up close, how light works.
Right, they have a massive visual library in their head.
Exactly. That's the machine learning part. The AI model is trained on these enormous data sets of high-res images and video. It learns all the patterns, the features, the relationships between pixels that make up a detailed image.
So it learns the rules of high-res.
Pretty much, yeah. Then you feed it a low-res image. The AI looks at the blurry patterns it can see. And using everything it learned during training, it makes a highly educated prediction about what details are missing. What should be there if this was sharp?
So it's not just a random guess. It's based on all that data it saw.
Absolutely. It's trying to estimate what the original scene would have looked like if it were captured in high resolution natively.
And then it draws them in.
It reconstructs the image, essentially. It generates new pixels, fills in the gaps with details that are plausible and coherent based on those learned patterns.
Wow.
And then there's usually a bit of post-processing, refining things, making sure the new details blend in naturally, avoiding weird artifacts.
Artifacts like, you mentioned the halo effect, What's that again?
Ah, right. The halo effect is that kind of bright or dark outline you sometimes see around objects if you sharpen an image too much.
Oh, yeah, I've seen that. Looks unnatural.
Totally. So good AI upscaling tries really hard to add detail without creating those kinds of problems. Finding the right balance is key.
Got it. So it's like one source called it a digital restoration magician.
That's a pretty good description.
It rescues fuzzy images, adds detail that just wasn't visible before, like hair looks more detailed, edges get sharper, landscapes suddenly have more clarity. Things basic stretching just can't do.
Exactly right. It's creating new visual information intelligently.
Okay, so the tech sounds amazing, but where is this actually happening? Is it just in labs, or are we, using this stuff?
Oh, it's definitely out in the wild. It's integrated into a lot of devices you might already own or use.
Like what? Where's the first place?
Well, a big one is televisions. Most high-end 4K and certainly 8K TVs these days have some kind of AI-powered upscaling processor inside.
Even if they don't shout AI on the box.
Yeah, sometimes it's just part of their picture processing engine. Samsung has their quantum processor, Sony uses X Reality Pro or their newer XR upscaling.
Ah, Sony's approach was a bit different, wasn't it? Something about a database.
That's right. The sources mentioned Sony compares patterns in the incoming low-res image to this huge internal database of high-res patterns. And that helps it figure out the best way to reconstruct the detail, aiming for really accurate color and brightness, too.
Interesting. Who else?
LG has their Alpha processors, Panasonic has their HCX processors. Most of the big brands are doing sophisticated stuff here. Sony and Samsung are often pointed to as being particularly good at it, according to the reviews we looked at.
Okay, so TVs themselves are doing it. What about other devices? Like streaming boxes?
Yep, good example. The NVIDIA Shield TV was actually a pioneer here. It was the first streaming media player to really feature AI upscaling prominently.
And what does it do?
It can take 720p or 1080p video streams and upscale them to 4K. And it does it in real time up to 30 frames per second.
While you're watching. That's impressive.
It is. It uses a trained AI model running on the Shield's processor, the Tegra X1 Plus Boker. And it works with, all the big apps, HBO, Netflix, Prime Video, YouTube, Hulu.
Huh. Can you see the difference?
They actually have a demo mode where you can do a slider, see the before and after side by side. And you can even adjust the level of detail enhancement, low, medium, high, depending on your preference.
Neat. Okay, so TVs, streamers, what about computers? Especially with graphics, like for gaming.
Oh, absolutely. Gaming is a huge area for this kind of tech. You've probably heard of NVIDIA DLSS.
Yeah, deep learning super sampling comes up with the graphics cards all the time.
Exactly. DLSS is arguably a form of AI upscaling specifically for games.
How does that work? Is it the same as video upscaling?
Similar principle, different application. With DLSS, the game actually renders at a lower resolution internally. Let's say it renders at 1080p or 1440p.
Okay.
Then the AI, running on the tensor cores in NVIDIA's RTX cards, takes that lower res frame and intelligently upscales it to your target resolution, like 4K.
And the benefit is?
Performance, massive performance boost. Because the main graphics chip is rendering fewer pixels to begin with, you get much higher frame rates.
Ah, so you can run games faster or turn up other graphics settings.
Precisely. You get the visual quality that looks very close to native 4K, but with the speed of rendering at a lower resolution. It's a really clever use of AI for gamers.
Yeah.
Used in their RTX 20 and 30 series cards, and newer ones too.
Makes sense. And outside of gaming, what if you're like editing video or photos?
Yeah, there's software for that too. These are usually standalone applications not designed for real-time playback like on a TV or with DLSS.
Okay, so for offline processing.
Exactly. Perfect if you have old family photos or maybe some older video footage you want to clean up and make look better for, say, an archive or a new project.
What are some examples?
The sources mention tools like Boris FX Continuum, which has an UpRes ML module for programs like After Effects, and also Topaz Labs Video Enhance AI, which is quite well known.
And these can do more intense processing because they're not real time.
Right. They can use really complex AI models. One source mentioned upscaling HD to 8K could take several seconds for just one frame of video, even on a powerful computer.
Wow. Seconds per frame.
Yeah, but the potential quality jump can be huge because they have that time to really analyze and reconstruct the details. You basically import your media, apply the effect, tweak some settings maybe, and then export that higher res version.
Okay, so that gives a good picture of where this tech lives. Circling back then, why is this important for you listening? What's the bottom line impact?
Well, the bottom line is it directly improves your viewing experience. Simple as that.
How so?
Think about all the content that isn't native 4K or 8K. Classic movies, older TV shows, home videos, even a lot of YouTube content or broadcast TV still isn't at the max resolution of your screen.
Right, lots of stuff.
AI upscaling takes all that content and makes it look sharper, clearer, just better on your modern display. It bridges that gap between the source and the screen, enhancing the visual fidelity.
It's trying to make it look like you were shot in high res.
Exactly, and it's fascinating how it does it. The algorithms aren't necessarily saying, that's an eyelash, make it sharper, it's more subtle. They're recognizing patterns of contrast and texture that are common in the real world.
More about light and edges than specific objects.
Sort of, yeah. It's learning the physics of how high-resolution images look, you could say. And engineers work hard to tune it just right. Add detail, yes, but keep it looking natural. Avoid those weird artifacts like the halo effect we talked about.
Right, the balance.
And for video, it gets even more complex. The really good upscalers don't just look at one frame at a time.
No.
No, they look at pixels across multiple frames, before and after the current one.
Why do that?
It helps make the upscaling more stable. It stops the AI-generated details from kind of flickering or fizzing as things move. You get a much smoother, more natural result over time.
That makes sense. Temporal stability.
Exactly. But, there's some limitations. Real-time processing on a TV chip, even a powerful one, isn't the same as letting a dedicated PC GPU chew on a single frame for seconds. So the results are impressive, much better than basic upscaling, but they are constrained by that processing power and time. And sometimes, though it's getting rarer, it can add a tiny bit of input lag, which gamers might notice.
Okay, so it's not magic, but it's pretty powerful tech.
Definitely a big step up.
All right, so we've covered a lot of ground. From the basic problem, fuzzy pictures on sharp screens, and the old, simple solutions.
The stretching and blurring.
Right. To this much smarter, AI-driven approach that actually predicts and creates detail.
Learning from millions of images.
And we've seen where you encounter it: TVs, streaming devices, gaming PCs, editing software. It's becoming pretty widespread.
Absolutely. It's all about making the most of the displays we have today, even when the content wasn't made for them. It's more than just stretching. It's intelligent reconstruction.
Well, thanks for joining us for this deep dive into the world of AI upscaling.
My pleasure. And maybe here's a final thought for you to chew on. If AI can get this good at convincingly predicting and generating missing visual details to make old pictures look real and sharp, how might that ability to create plausible, even realistic visual information affect how we perceive reality in other digital spaces? Something to think about.